Alright, this video is going to be going over the Braitenberg vehicle type in the latest version of Quelea. You can find this type right here. Construct vehicles, that's what I have here. It's an extension of an agent. So these vehicles were originally conceived of by Valentino Braitenberg. They are two-wheeled vehicles in general, and they have also usually two sensors. And the sensors power the wheels, so based on the readings that the sensors get, usually based on some sort of source, it'll power the wheel more or less depending on how strong that reading is. Here you can see, depending on which wheel the sensor is hooked up to, the vehicle is going to behave differently. So in this case, if this one reads a very high reading and this one reads a lower reading because it's farther away from the source, it's going to turn this wheel faster. And because it's turning this wheel faster, the effect is that the vehicle will turn away from that source. Conversely, if you hook up the sensors to the opposite side, then you'll see that when this one reads a higher value than this one, it's going to turn this wheel faster, and the effect is that it turns towards the source. So we can see that here. I have my vehicle and I have my source, and here I'm saying indeed cross those wheels, so it should steer towards it, and indeed it does. Whereas if I were to flip this to false, we should see that, alright, so it's, there we go. So part of, the things you have to deal with Braitenberg vehicles are, say, if the source is directly in front of the vehicle, then both of the sensors are going to read the same value, right? Because the distance to the source is the same. So here, if I show, you may think that it's steering towards it because it's crossed, but even if I change it to false, you'll see that it's still going to steer towards it because, again, both sensors are reading the same value, and even after they go past it, they still read that same value, and no matter what I do, we see that it stays on its trajectory. However, if I move this point, you can see now one of the sensors is going to read a higher value than the other, and it's going to cause the vehicle to turn. So some of the things to take into account are the wheel radius. So the wheel radius is going to determine kind of how easily it's able to turn. So if I were to create very, very small wheels, and let's rerun the simulation, because it has to turn those wheels a lot more to create a turning effect, we get a much slower turning radius. Whereas if this wheel was much higher, we can see we get a very high turning radius, and it almost immediately jumps right to that source. Okay, so that should be enough of an introduction, and I'm going to jump into, so that's the sensory point force. But you can also do things like have a kind of image field. So in this case, the source is going to be these brighter luminance values, and we should see that the vehicle kind of steer towards these brighter luminance values from this bitmap, which is actually a solar radiance map. So this was done in Ecotech, and then I took it into Grasshopper. But you can see here, this was the original solar radiance map, red being a lot of sun and blue being shadow. So here I just kind of took that image, this kind of image that turned black and white, I brought it into Photoshop, and I applied a little blur to it to get this image, and you can see that effect here. And as you zoom out, you get a better blurry vision. Really, these are just points that are colored. So that's that, and so now I have these vehicles that are lined up on the edge of this image plane. So I'm using a surface environment, and my surface environment is this here, and I made sure that my image is the same size as, or the same ratio as this environment. Alright, so I got my surface environment, I got a bunch of these point emitters that are lined up, that are lined up on the sides there, and then I tell them that, head towards the center of the thing, right? So let's, and then over here we have our sense image, and here I'm using this load image utility that allows me to load this bitmap image that you feed into the sense image, and here you just give it the file path. And this thing actually doesn't recompute every round because it's actually kind of expensive to reload a bitmap, and so if you do change it, you hit this button and it'll refresh that image. Okay, let's run this guy. So here we can see each vehicle has its two sensors that are positioned in front of it, and these are kind of determined by that vision radius and vision angle. And we can see that they are, certainly congregating in those brighter luminance values. So here, up there, here, there, and they're kind of avoiding these darker areas, and they're congregating here. And you can, of course, change the multipliers. So if I wanted them to look farther in front of themselves, right now it's set to 0.2. If I were to set that to, say, 0.5, might have been hard to notice, but, it spreads them out more and more, right? And the vision and the angle multiplier does a similar thing, but it determines the angle around the vehicle that the sensor will be. So here, as I change this, you can see they kind of rotate around the vehicle until it's behind. Here it's in front. The default values are usually pretty appropriate. So here we go. We see over time we are definitely getting a nice interpretation of where the areas of greater shadow are. Remember that the white is corresponding to areas of shade. And so I'm going to pause this simulation, and I'm going to, so they're actually running on this flat plane, which is this unrolled surface, but here I'm going to map them back to that surface, and we get to see the results of that on the surface. So you can see this area, it's this area, I believe this should be this over here, and then down here, that's this area as well. So you can see they are definitely avoiding the areas where there's a lot of sun, and it looks a little bird's nesty right now, and maybe a little too crazy, but remember that you can kind of start to tune how much the Braitenberg vehicle force is affected by adding other forces. I created another video where I showed an example where I was using a seek force to ensure that they stayed more or less on the same path across. You should check out that video if you haven't already. There you go. That was just a mildly quick introduction to Braitenberg vehicles, and one thing you can do with it, which is kind of map them across a solar radiance analysis. But if you have other analyses that produce bitmaps, like wind analyses, you can also use that, or you could use these points, and as you add multiple points, you'll see you get different effects. So just play around with it. They're pretty fun. And remember to kind of add in agent forces as well. So that's it. Thanks.